Activity 6, Stop and Think, Part B, Mendel's Experiments with Pea Plants. This is the first of 2 parts. Plants in general, and pea plants in particular, were excellent organisms for Mendel to study for the following reasons. They grow into mature plants, that means adults, very quickly. In about 60 to 80 days, their seeds grow and develop into mature or adult plants. So remember, 60 to 80 days. There's approximately 30 days, as a side note, in a month. So you're looking at just over 2 months. Going on. They produce many seeds rapidly. They have many observable characteristics that come in just 2 alternatives, such as purple or white flowers, yellow or green pods, with no blending of these traits. No lavender flowers, no yellowish green pods. As a side note, this is kind of like when we're looking at Sky and Poppy. They had blue and orange. Their offspring did not have a blend of the traits. There were just 2 options that we can pick from. Not all traits, we will find out, act like this. Going on. We have a table right here with results. Notice that we have the parents, which we will call the first generation. We have 2 options for flower color, purple or white in that parent generation, green or yellow seeds, wrinkled with dimples or smooth, and green or yellow pods. The pods are what contains these seeds. If these parents, first generation, were to have offspring, we call those the second generation. The only option for second generation were all purple. The only option for the second generation, if the parents combine, if we have a green and a yellow combined, is all yellow. If we have a wrinkled and a smooth parent combined, we have all smooth offspring. And if we have a green and a yellow pod color, all green. And then we have different ratios. The third generation offspring, it has these numbers, 705 to 24. This means there's 705 purple, that's the first number, offspring, to 224 white. So there are more purple than white. Same thing here, 6,022 yellow, because that's the first number, first color mentioned, to 2001. And so on and so on. So Mendel decided to breed extremely large numbers of pea plants and search for simple patterns in the offspring. Side note, the reason we do large numbers is because we have less chance for random errors and random mutations, which we still have to talk about later on. Okay, so it gives us more reliable results. The more trials you do, the more reliable your results. Going on. The table above shows the results he obtained for 4 of the characteristics he studied. Mendel did hundreds of crosses and observed and counted the offspring's traits for thousands of pea pods, seeds, and flowers. He then analyzed, side note, that means looked at to try to figure out what it means, going on, all the results and applied his knowledge of statistics and probability to infer. Infer means to make your best guess. Infer the behavior of individual genes. So in this section, the first question is, what were the advantages for Mendel in using pea plants? So you have to go back up into the table or up into the reading and figure out why he used pea plants. And they gave you a few bullets for that. And then part B says, why did Mendel perform so many crosses? And I told you that in the reading. And I want you to also think about what you can come up with, okay? So go back up and listen to what I said as a side note, or go back up into the reading and make your best guesstimate.